haven't done anything yet, right? Okay, so I want to thank Bogdan because he gave a decent overview of the, how would I say it, of the ecosystem, right? And my talk would be more down to the earth, more like attempt to survive, because I'm pretty new to GraphQL. So let's begin. Pursuing Singularity. It turned out that there are a lot of definitions for this world, and we will be using one from that is used in system design. It was coined by James Maxwell, and he says that, well, singularity is a small change that can cause a large effect. And the more singularities or singular things you have in your system, the more complex it is. And for me, it resonates well with one of development principles, right? I don't know which one is it. It's in the name, dry, right? Don't repeat yourself. So it was quite a surprise for me when I started working on a GraphQL app 6 months ago that I really need to make a lot of changes to make one single thing happening. And hence, I'm here in front of you today. We'll try to reduce the number of singularities in our GraphQL projects, thus making it more resilient and bringing more joy into developing it. My name is Paradeev. I write code professionally for 10 years, which means I write code for money and sometimes for food. I'm still new to GraphQL. Like, I know this, I'm using this thing for 6 months. That's why I will bring to you some kind of outsider perspective, right? So I will question everything, every tool and every decision we are making. I'm a software engineer at Klarna, and there I'm helping my team to evolve the architecture of an Electron app. Who is writing Electron apps here? Mobile developers, raise a hand. Web developers? Okay, so I'm the only Electron app developer here. Well, good to know. We're using the same icon, so I think you are pretty much familiar with this structure right now. So we have a backend for frontend, right? We have a database and we have an Electron app. And you can put there your client, either a mobile application or a web application, right? It's a pretty generic structure. We have a client, we have a server, which exposes GraphQL API to the client, and we have a persistent layer, so backend can store data and fetch data back. So, think for a moment. In your project, how long would it take to add a new field in one type to a client? So given this demo project, we have a couple of routes, right? We have one query for users, we have one mutation. We can ask for users and we will get, how can I close it? We will get 2 fields. How costly it would be to add another field, to add age for a user? How many places in your code base you would update? Can you give me some estimate?
3.
3, nice.
4,
5, okay.
3.
1. Thank you. You can leave, actually. There's nothing for you to learn about. But I have some question for you. Yeah, so I believe max was 5, right? Maximum value. So for me, it was 8. And it consists of a couple of changes in the schemas. We have schema for database, we have schema for GraphQL. We have queries on the client. Client is not aware what the schema on the backend is. We need to actually type it. And since we are using Typescript, we need to create types as well, manually. And it's just too much. It's error prone, it's not scaling well, you cannot teach everyone in your team to do that. These changes get out of sync, you'll get errors in your code. So we probably can do better. And today we'll try to slice these problems into groups and solve them one by one. So we will start with types. Okay, this is our resolver. And resolver is a function to provide data for a query, right? So we have two resolvers here, one for mutation, one for query. And who sees the problem here? What's the problem? What's problematic in this code? I would say that I create the type of a user myself doesn't mean that it is the type I will fetch from my database. And it was a case in a couple of times with our project. So we, let's say, add something to the database and forget to fetch it. Or more dramatic thing, vice versa. We add a field to a type and we forget to add it to migration. And we get an error in staging or in the production. The same for a client. Here we have a pretty obvious duplication of code. We have a type in a query and a type in our, like an interface for our return type. And since these two objects are in different files and probably changed by different people, they can get out of sync. So what can we do? We can use code generators. Can you raise your hand if you're using a code generator for types? It's actually less than I'm expecting, because I was afraid that like everyone is doing that and I just figured it out. Well, good then. So the idea is to infer type from a schema. And we have a couple of decent tools. One is Apollo CLI, another one is GraphQL CodeGen. We install a couple of packages for a client, for a server. Then we create a config where we say, okay, we need types that we want to infer from a schema. And then we say which plugins we need to use and which types do we need. Here, I would like to have types for our resolvers. And for client, it's slightly more complicated. I'm using not only schema from the backend, but also a file where I define queries. So I want to infer types for my queries as well. So with one command, I get this. I get generated types for both client and server. And I can use it like this. Click. Oh, it's pretty exciting. I no longer need to type it manually, both for server and for the client as well, right? So we have an interface. We can import get user query. And the nice part is that if I add another field for get users query and regenerate types, this field will be propagated to this type automatically. I do not need to think about this. So we solved two pain points out of 6. The next problem is clients. If you are using a SQL database, let's say, you need to query data from it somehow. And one way to do it is to use a SQL builder. I think someone should be familiar with Next, right? If not, it's just a query builder, and I might as well be writing plain SQL queries here. The idea is that I need to define shape of the object I'm receiving from the database and put it manually here, and I'm just hoping that it will match because the database may have a different schema. The same for the client. On the previous step, I was pretty proud with this code. Now I start to doubt. Is this query even supported by the backend? Maybe something has changed in the meantime. Will I get an error? I don't know. So we can throw more code generators in it, or I would rather say client generators. And we have a couple of tools, right? And it should ring a bell. For client and for server as well. So now we can get rid of our migrations of our SQL schema and put all of our domain knowledge in a Prisma schema. Here, beside this user type, we can say which database are we querying from, and we also say that we want to generate Photon. So what's Photon? It's a database client. So we execute these two commands, and we have this. GraphQL Zeus, it's a pretty nice name given that we are in Berlin. GraphQL Zeus is a client that is generated specifically for your backend, and we will see in a moment how you can use it. Schema is generated by Prisma, but here we have generated folder inside node modules, right? And in a moment we will see why it is not like placed in a generated folder. Why is it convenient to put it in node modules? So, given our SQL queries, what would be different with Photon? We are not using types anymore, right? We are not explicitly telling Typescript what we expect to get back. Photon is taking care of it. And here, what we cannot see here is that this name attribute that we are passing to create function and find many also has a typed attributes. This is generated, this is tailored for our database, which means we cannot pass in some arbitrary attribute here. It's type safe. And this is my favorite feature. I haven't seen this in any other tool. Do you have this problem when you query against a database and the type that you have back contains every possible field that a table has? And you need to either check or hope that this field is actually queried, because you may query for a subset of these fields. And this was a huge problem for me. Photon can infer return type. So when I say that I select only ID field, this user without name will not allow me to access name field. So for our team, it was a huge win. And for client, it's pretty much the same. It's type safe. It guards us against providing invalid data. And for now, interface, I would say, is a little bit clunky, but I guess it's in development, so we can hope for a cleaner interface in some time. Okay, we are pretty much done. The last part, right? We are still typing schema, GraphQL schema, as a plain text in a GraphQL file. And the problem is that schema is only like half of the equation. We also need resolvers, and they are separated into two different files, and they need to mirror each other. And I figured out that there is like a known problem, and there is an approach that is called code first, which means that using some tools, instead of writing schema in plain text, we can code it, and it will be type safe. So here we are saying that, okay, we have a query that will expose a getter for users. We have a user type, and we can control which fields of a user table we can expose, which means if a user has a password field, we can decide not to expose it to the client. So everything is green, right? No more tears. Not really. Prisma 2 is not production ready, and it's not a surprise, right? There is a site that is called "Is Prisma 2 ready?" and it's written, no, it's not. And we are using it in production, and it's not ready. So one of the problems that, for me, coming from a REST, like SQL-ish background, I love joins, was very surprising. So it seems to be normal in GraphQL land that when you query for entities with nested relationships, you can get n queries instead of one query, because GraphQL cannot join by its own. We need to use some additional tools like data loader, right? And Prisma cannot do that now. It will do, as far as I'm concerned, but it cannot do it now. And in our production application, we were able to fetch, I believe, as many as 100 top-level entities. So we need to fix it, right? I don't like to switch back to Nex altogether. Well, we can find a compromise. So we have Photon, and we have Nex that is working. Why not use both, right? Prisma will still generate us types. We can still use Nexus. I think it's a pretty valid approach to do that. So this is our current state. We are waiting for Prisma 2 to be released. We are quite happy with performance because Nex is solid, and I think it's fine. So I think it's fine. Okay, so now a couple of ideas. I will not call them advices or rules or principles because they're just empirical. They work for me. They may be not universal. A couple of things that I wish I would know 6 months ago. So the major theme is treat as any tool as disposable. GraphQL is still pretty new, and a lot of things are changing every day. For example, we start with Prisma 1, and it was basically, I'm not sure if it's like sunsetted or stopped development.
It's in maintenance mode.
Maintenance mode. At Nexus is dropping Prisma 1 compatibility, right? So everything is changing rapidly, and it's normal. But that means that you need to separate your concerns. It means you should decouple your modules as hard as you can. So when you keep your modules separate, you can pick and choose which tool are you using, and you can throw away tools that are not working for you. So one problematic point, and Bogdan was telling us about this, is you shouldn't expose your API schema, how do you say it, implicitly, because it will create a coupling between your database layer and your client, and it will be very hard to update it, to break this coupling. So this is my takeaways. This is a repository. If you want to compare like the previous state and the current state of the tooling, you can visit it and play with the code a bit. Probably send me a PR if you know how to make it better, because I'm still new. What can I do? What can I know? And this is a list of tools you can play with. And if you haven't implemented this code generator, if you're not using it, please go ahead, find 5 minutes. It will not require any change in your code base, just a config on top of it. And if you are brave enough, go play with Prisma. Prisma 1 is solid. You can use it in production. Hasura and PostgreSQL are alternatives. I haven't tried it, but they kind of working in the same field. And feel free to play with it and have fun. This is it for me. Thank you. Any questions? Then we are good.
So how do you, it's not a graphical question, but how do you convince your team to go to production with, even if there is a website that says Sigma, that Prisma 2 is not ready?
Oh, that was a fun story. So the honest answer is that Prisma 1 has a pretty specific requirements for deploying, because Prisma 1 introduces this standalone proxy service, which means that when you deploy something, you need to be able to deploy 2 services in one time, in one go. And we were using deployment system that not allow us to do that. So we were forced to switch from Prisma 1 to either the future or do a step back. Which is the future? Okay, thank you. You're a great crowd.